Welcome to another session of learning and practice. As mentioned in the AC method presentation session, during this session we will go through some examples of factorizing and solving quadratics using the AC method. In our first example, we have a is equal to 2, and then we have the two factors b and c, which in this first example will be positive values. So c is plus 14 and b is plus 11. I'm going to use the AC method in order to factorize first and then solve this quadratic equation. Now, first step, as we've seen before in the last session, we're going to calculate the value of AC. Well, hence the name of the method, AC method. Now here the value of A is plus 2 and the value of C is plus 14. So we're going to do plus 2 times plus 14, which gives us plus 28. Like we've seen in the previous session, we're going to factorize this 28, looking for the factors of plus 28. Now we start with the simplest factors, or pair of factors. So it's 1 and 28, and then we work out the rest of the factors from there. Times by 2 is 1, divided by 2 is 14, so the second pair is 2 and 14. Now times by 4, divided by 4, gives us the third pair, 4 and 7. Now we find the list of factors for 28. We're going to decide which two factors are going to add up to give us the factor of x, which is the sum. Now we need two numbers that would give a sum of plus 11. That will help us identify the matching factors. So the sum is positive, so again the larger factors must be positive. So 28, 14 and 7 are positive. Plus times plus is plus, and the smaller factors are also positive. So all these factors now are going to multiply to give us the plus 28. But we have to identify which two are going to add up to give the factor of x with the value of b, which is plus 11. In other words, the matching factors this time are going to be 4 and 7, because plus 4 plus 7 gave us the value for b, or the factor of x, which is plus 11, and we found our matching factors. Now we're going to associate those factors to x and incorporate those two matching factors into our quadratic equation. So the quadratic equation can be written now as 2x squared plus 4x plus 7x instead of the 11x. So 4x and plus 7x, the matching factors, have been incorporated in our quadratic to substitute the value of 11x. Now we found the matching factors, they're incorporated in our quadratic, so we can start the factorization process. As we've seen in the previous session, we're going to look at the first two terms and the second two. So 11x is 4x plus 7x. Now I'm going to use them to factorize. The first step, factorization. So the first two terms and the second two, 2x squared 4x, and then plus the sign in between. We're going to keep that sign, 7x plus 14. So the first two terms, highest common factor is 2 and then x. So you have a common factor, 2x. So 2x is going to be multiplied by x to get 2x squared and then plus 2. So 2x plus 2 gives us back the 4x. Now notice we're going to keep that sign, the positive sign, before the next two terms. Highest common factor 7, and that factorizes as 7 times x, and then to get the plus 14 plus 2. So 7 times plus 2 gives us the plus 14 equals 0. First step, factorization. Now we're going to fully factorize by looking at the common factor. In this case, x plus 2. So x plus 2 is a common factor for those two terms. So it's going to be taken out as a common factor. So you're going to have x plus 2, and then to get 2x times x plus 2 back, we're going to multiply x plus 2 by 2x. So 2x is the first term on second bracket, and then x plus 2 times plus 7, so the second term is plus 7. Notice I'm keeping that sign plus between the two terms, equals 0. Now it's fully factorized, we can solve. Same principle we've seen earlier with the simple method and the AC method. If two factors multiply to give 0, then one of them must be equal to 0. So you're going to have either the first factor, which in our case is x plus 2, has to be 0. Simple linear equation, minus 2 on both sides. To get rid of it, we do the opposite. So, and therefore, the first solution, or the first root, is x equals minus 2. Or, the second possibility is for the second factor to be equal to 0. So in our case, we have 2x plus 7. So 2x plus 7, the second factor, is equal to 0. Now we're going to solve simple linear equation, minus 7 on both sides. So we're going to end up with 2x equals minus 7. Times by 2, the opposite is divide by 2, so dividing by 2 both sides gives us the second root, or the second solution, x equals minus 7 over 2, and we have factorized and solved our quadratic using the AC method. Now, of course, it's not going to work for all quadratics. We'll see other methods in coming sessions, but that's the first example. Now, we're going to look at the first example with b and c positive. In the second example, we're going to see what happens if the values of b is positive and c is negative. Now a is still greater than 1, so a equals plus 8, and then we have c equals minus 2. And we have the values of a and c. So step 1, we're going to calculate then the value of a times c, and look for the common factors, and then factorize to find the matching factors that would add up to give plus 15. But first, let's calculate 8 times c. So a is 8 times c is minus 2. So this time we have a positive, c negative, and b positive. So the product is minus 16. Now we need to look for the factors of 16, starting with the simplest one, 1 and 16, then times by 2 is 2, divided by 2 is 8, that's the second factor. So we have 2 times 8, and then times 2 is 4, divided by 2 is 4, and the third pair of factors, 4 and 4. Now we found all the factors of 16. Then we have to decide on the sign. Like we said, in order to find the sign, we look at b and the sign of b. b is positive, so the sum is positive. That means the larger factor must be positive. And then plus times minus is minus, so the smaller factors are negative. Now all those factors now will multiply to give minus 16, but which ones will add up to give plus 15, which is the value of b, or the factor of x. Now in our case, the matching factors minus 1 and plus 16, because the sum is plus 15 and the product is minus 16. So we found our matching factors. So we're going to incorporate that in our quadratic in order to solve it, to factorize it first and then solve it. So let's incorporate. So we're going to have, instead of 15x, we can substitute it by minus 1x or minus x and plus 16x, because we found the matching factors by looking at all the factors of 16. So you're going to substitute it by minus x and plus 16x. So that plus 15x can be written as minus x plus 16x, and then the last term remains the same, minus 2, equals 0. Excellent. Now we can start the factorization process by looking at the first two terms and then the second two terms. So 15x has been replaced by minus 1x or minus x plus 16. Let's look at the first two terms, second two terms as we mentioned, keeping the positive sign plus in between. Now ax squared minus x, looking at the highest common factor, now in this case is x. So you're going to take x outside the bracket and factorize our two terms. So x times 8x to give us 8x squared back, minus x times 1 to give us x. Now keeping the positive sign intact in between, and then we factorize the next two terms. 2 and 16, highest common factor is 2, and then it's going to be 2 times 8x to give us 16x, and then 2 times minus 1 to give us the minus 2 equals 0. So first step, factorization is done. It's not completely factorized. Now look at the common factor between those two terms to fully factorize our quadratic. In our case, we have 8x minus 1 as the common factor. So I'm going to take it outside the bracket. So I'm going to have 8x minus 1 as a common factor times x to give us x times 8x minus 1, so x, and then plus 2 to give us back 2 times 8x minus 1 equals 0. Now our quadratic is fully factorized. We can solve using the same principle we've seen for the AC method in earlier sessions and the introduction to the AC methods. If two products give a product of 0, so it means one of the factors must be 0. So in our case here, the first factor, 8x minus 1, must be 0. We're going to solve it, plus 1 on both sides to keep the balance. So on the left hand side, we're going to have 8x equals 1. The opposite of times is divide. We're going to divide both sides by 8, which gives us the first solution or the first roots, x equals 1 or 8. And that's the first solution. The second possibility is for the second factor to be equal to 0 in that product of the two factors, and x plus 2 must be 0. Minus 2 on both sides to keep the balance again and solve this simple linear equation, and we end up with our second root, or our second solution, x equals minus 2. So first case was b and c positive. Here we have b is plus 15, c negative, minus 2. I'm going to look at the third example. We're going to change again the signs and see that the algorithm still stands and still works. So here we have c is negative and b minus 11 is also negative. Okay, so let's work out the product a times c, go through the method, go through the algorithm, and show that it will work in this case as well. So let's find our factors here, a and c. So a is plus 3, c is minus 4, and b, which is the sum of our two factors for the product ac, should be minus 11. Well, let's work out first a times c. As the method indicates, AC method, so a is plus 3 times c minus 4. 3 times plus 3 times minus 4 is minus 12. And let's look for the factors of 12. So the factors of 12, simplest pair of factors starting with 1 and 12, and times by 2 is 2, divided by 2 is 6, 1 times 3 is 3, and 12 divided by 3 is 4. And we found all the factors of 12. Now we have to decide on the sign again. So we look at the sum, or b, the factor b. There's minus 11. The sum is negative, so the larger number must be negative. And minus times minus is plus. The smaller number must be positive. The sum is negative, the larger number negative. So all these factors would multiply to give minus 12, but only plus 1 and minus 12 would add up to give minus 11. Now we can incorporate those two matching factors in our quadratic. So instead of writing minus 11x, we're going to write plus 1x or plus x minus 12x. So plus 1x minus 12x to give us minus 11x. So the equation becomes 3x squared plus x minus 12x, which is our minus 11x, and then minus 4, the last term, equals 0. Matching factors are incorporated in our quadratic. Like we've seen before, you know what's coming next. We're going to factorize the first two terms and the second two terms, keeping that negative sign in between them. So let's factorize now after incorporating the matching factors to get minus 11x. So the first two terms, x is the common factor. So it's going to be x times 3x plus 1 to give us back 3x squared plus x, and then keeping the negative sign, so minus. I'm going to factorize the next two terms. The highest common factor is 4, so it's going to be 4 times 3x, and then minus times plus is minus, so times plus 1 to give us minus 4. So minus 4 times 3x gives minus 12x, and minus 4 times plus 1 gives minus 4, equals 0. Now it's not completely factorized. We look at the common factors between the two terms, 3x plus 1 in this case. So we're going to fully factorize now by taking 3x plus 1 as a common factor. So 3x plus 1 is our common factor, multiplied by x to give us back x times 3x plus 1, and then multiplied by minus 4 to give us minus 4 times 3x plus 1. Now it's fully factorized. We have two factors again that multiply to give 0. So, like we've seen before on all the examples, one of the factors must be 0. So first case, we're going to have either the first factor, 3x plus 1 equals 0, back to linear equation, easy to solve. You do the opposite, minus 1 on both sides to keep the balance, which gives us 3x equals minus 1. Times it by 3, the opposite is divide by 3. Whatever we do to one side, we do to the other side to keep the balance, and that gives us the first root, or the first solution, x equals minus 1 over 3, or minus a third. That's our first root, or the first solution. The second possibility is you have the second factor equal to 0. So in our case, x minus 4 is equal to 0. Plus 4 on both sides to get rid of the minus 4 and keep the balance. That's what algebra is all about, really. Keeping the balance between the left-hand side and the right-hand side. And x equals plus 4, 4. That's the second root and the second solution. So we've seen different examples on using the AC method to factorize and solve quadratics. In next sessions, we're going to look at other methods and then the more general method towards the end. Thank you for watching. We hope you enjoyed it. Don't forget to subscribe and see you next session.